All right, this is from Openstax Precalculus, section 3.6, number 43. Find all complex solutions, real and non-real. X cubed minus 8x squared plus 25x minus 26 equals 0. So for our solution, what I'm going to do is first list the possible rational roots which are factors plus or minus of 26 divided by factors of 1. Why am I getting this number? This is the constant coefficient, and this is the lead coefficient. And so the rational root theorem says that I take the factors of 26 and divide by the factors of 1, and those are the possible rational roots. So a root or a 0 is a number that you put into the polynomial and it equals 0. So a possible answer per se is something like square root of 2, but that's not a rational number. So a rational number is a fraction of whole numbers or fraction of integers. So let's see what works here. So we can list the factors of 26. We're going to have 1 times 26 is 26, 2 times 13. So there's not that many factors. And then a factor of 1 is just obviously 1. So we have the possible rational roots are going to be plus or minus 1 divided by 1, plus or minus 2 divided by 1, plus or minus 13 divided by 1, plus or minus 26 divided by 1. Okay, and so then we just check to see if any of these work. So if I have f of x equals this polynomial, then you might want to look ahead, but I think 1, hopefully that'll work. So it could very well be that none of these work. (25 minus 26, negative 1). So that's not going to work. That's just going to be negative 8. So you can maybe try to look ahead and do this in your head a little bit. That's not going to be 0. This method is definitely slow going though. This is 8 times 4 is 32. This looks like it might do it. This is 8 minus 32 is negative 24. So that makes 0. So x equals 2 is a 0. Therefore, x minus 2 is a factor. So once you get one factor, you sort of crack the whole thing because it's only a third degree polynomial. And what we can do is we can divide x minus 2, oops, maybe I do it down here, x minus 2, we can divide that into our polynomial, and then the result will be this factor x minus 2 times a quadratic, and then we can use the quadratic formula to find the zeros of the quadratic. The whole time you have to sort of look to make sure that there's no mistakes going along here. This is just a little nothing. Okay, x squared, this makes x cubed minus 2x squared, subtract plus, that makes negative 6x squared, bring down minus 6x, and we add the opposite. will I finish it? Will I fit this down on one piece of paper, maybe? And then plus 13. I don't know why I wrote that. Okay. Oh, well, there we go. Okay, now, all right. So I shouldn't be surprised that there's a remainder 0. I don't know, for some reason I was for a second, but I shouldn't at all, because we know x minus 2 is a factor, so we know that it divides evenly. Okay, so that perfectly makes sense that you have a 0 remainder. By the way, you could use synthetic division. I chose not to. So what this means then is that the get this all on one page, on one screen. Okay, what this means is that f of x is equal to x minus 2 times x squared minus 6x plus 13. And now you look at this guy, and so what do we have? We have x minus 2 equals 0, which is x equals 2. We already knew that. X squared minus 6x plus 13 equals 0. And we're going to find zeros for this. You can use a quadratic formula. Actually, I've been sort of really big on completing the square and finding zeros that way. But let's just use the quadratic formula. The only thing I see with quadratic formula is that so many people make mistakes when they use that. So we have x is equal to negative b plus or minus radical b squared minus 4ac over 2a. So that's going to be, just copying down those numbers, opposite of negative 6 plus or minus negative 6 squared minus 4 times 1 times 13 all over 2 times 1. And, you know, you start getting some bigger numbers, maybe. Well, maybe not that bad. So this is 36 minus 52 over 2. I see people, like there's some people who can multiply and add numbers really easily in their heads. Maybe if I worked on that all the time. Okay, now that's the square root of a negative number. That's not a real number. That's a complex number. So, or it's going to be an imaginary number. Okay, so that's my answer. Do not divide the 6 and the 2. So many people do that. Don't divide the 6 and the 2. What you do is you can write this as 6 divided by 2 plus or minus 4i divided by 2. So 6, 3 plus or minus 2i. So it's true that 6 divided by 2 makes 3, but you have to simplify this and divide also. And so the zeros apparently are x equals 2, x equals 3 plus or minus 2i, so there's 3 zeros. And then extra, which no one needs, but I just end up doing stuff like this. It's a compulsion. As an extra, I just want to show you how we could complete the square. To solve. And more and more I think that's easier. So I have x squared minus 6x equals negative 13, and then what I do is I complete the square. I take the coefficient of x, which is negative 6, divide by 2 and square it. That makes 9, and I add 9 to both sides, because, you know, to make the equation equal. And then the left-hand side factors to x minus 3 squared equals negative 4, and then I take the square root of both sides. It really is the same thing as the quadratic formula, but I think that maybe someone would be less likely to make a mistake using this. I see so many mistakes on the simplifying under the quadratic formula, and so maybe this one, if you can get this, is less likely to make mistakes. However, in either case, if you end up, see when you divide by 2, we got negative 3 and then we squared it. If we get a fraction and you squared it, the whole thing becomes a lot of trouble. So, but maybe I think that would also show up in the quadratic formula. Okay, that's all.